Continuation from our last class, today we are going to look into the application of logarithm. Consider this relation. If you are told to multiply this without the use of calculator, it will be a lot of headache for you. Because altogether we are having 8 digits here. I mean we have just 2-3 digits, we can just neglect decimal points and multiply normally as we did in our previous lessons. And we know in mathematics it's easier for us to add than to multiply. Then recall. Suppose we have to number A times B. Instead of multiplying this number, if we are to put them in logarithm form, so this is something as log A plus log B. So what this is telling us is that instead of us to multiply before convert it to log, we can look for log of A, the log of B, and we add instead. But after addition, our answer will be in logarithmic form. That will be a power. So we have to return it back to the normal form. And that is what we call the antilog. Suppose after we added this, our answer is Z. So if we look for the antilog of Z, we'll get the correct answer. So the antilog of what to get here is the correct answer, which is the product of A and B. So for every number, the first thing we have to do is to convert the number to log form. So the question is, how can we know the log of these two numbers? Although we can use our calculator, because the calculator expresses, we can use the calculator to get the logarithm of any number to base 10. But the thing is, if we have our calculator, then we don't need to even do this, just apply directly. So but here, we want to assume that you don't have a calculator. Then in this case, you have to use the logarithm table. It's a table from which we can get the logarithm of any number, particularly if the digit doesn't exceed 4. This is what the table looks like. So here we have the numbers 11, 12 to 54 here. Then we continue until we get to 99. So the first thing you have to do is to express this number in standard form. So 26.71 is something as 2.671 times 10 to the power 1. Then 307.7 is 3.077 times 10 to the power 2. So the logarithm of the whole of this is the log of this plus the log of this. And the log of 10 to the power 1 is 1. The log of 10 to the power 2 is 2. If the base is 10. And in this case, the standard base is 10. So the power here, we have to write it here and write 1 point. Here also, we write 2 points. So we go to logarithm table. So we neglect decimal points. So we have 2671. So for the first 2 digits, you check 26 under 7 under difference 1. So what will be the logarithm of this one? 26 under 7 difference 1. Let's show it. So this is 26 under 7. This is 7 here. We'll come down. So this is 26 under 7. 4265. 26 under 7 is 4265. Then under difference 1, we'll go to the difference column. So 26 under 7, 4265. Difference 1. This is difference 1. Difference 1, what do you have there? 2. So you add a 2 to it. And now give us 7, 6, 2, 4. So 4267. So it means the logarithm of 26.71 is this, 2 base 10. So if you do 10 raised to the power this, we get this. Now let's go for the second number. 3077. We check 30 under 7, difference 7. So this is 30 under 7. This is 7. That's 4871. 4871, then difference 7. Difference 7 will come down to 30. And that's 10. 10. So 30 under 7 is 4871. Difference 7 is 10. So we'll do 10 plus 4871. 4871 plus 10 will give us 4881. So this will be 4881. And that's what we write here, 4881. Now, because we have multiplication here, for the log of the numbers, we add. And by the time we add, what are we going to get? So 1 plus 7, 8. 8 plus 6, 14. 1 plus 2, 3 plus 8, 11. 1 plus 4, 5 plus 4, 9. That's 3.9148. So this represents the product of this number in log form. So what happens? We have to return this to original number by taking the antilog. So the antilog of this will give us the final answer to the question. So we need to go to the antilog table for this. This particular table is for logarithms of numbers. Let's not use antilog. This is for antilogarithm of numbers. And to look for the antilog, we focus on the mantissa, not the integer part, this mantissa. So we have 0.91 under 4 difference 8. So we check 0.91 under 4 difference 8. So where is 91 here? Where is 91? So this is 0.91. 0.91. Under what? Under 4. 0.91 under 4 is under 3. This is under 4. 0.91 under 4. This is 4. 0.91 under 4 is 8204. 8204. Then we have difference 8. 8204. Then the difference. Let's check it. So this is difference 8. Let's stretch it down to 91. That's 15. 91 to 8. So we are going to add 15 to it. So let's add. We are going to have 9, 1, 2, 8. So the antilog is 8219. How do we now know where the decimal point to be? That's the function of this integer part. So this 3 actually means 10 to the power of 3. Note that we use 0.91, so the decimal point is here originally. Then move it 3 times to the right. 1, 2, 3. So the final answer is 821.9. Oh, sorry, there's an error here. The decimal point, since we converted this to standard form initially, standard form. And for standard form, decimal point will be after the first digits. So it means originally the point is here. They will shift. We are going to start a shift from here. The shift will start from here. So we are going to shift from here backward, start it forward to the right 3 times. So 1, 2, 3. Decimal point will be behind 9. Since there's no number there, we just write as what? 8,219. That's the final answer. Please note that. So that's the solution to the first question. Now, what if what you have is division? What if you have 26.71 divided by 307.7? We know for division, we are meant to subtract. Just note, whenever we have multiplication of 2 numbers, in logarithm we add. If you have division, in logarithm we subtract. If you have power, let's say number to a power, in logarithm we do what? We multiply by that power. So what if it's radical power? We do what? We divide by that power. For example, for this power, if I have a number, let's say x squared. In logarithm, I'll multiply the number I got by 2. If I have square root of x, there's invisible 2 here, that's something as x raised to 1/2. So that'll be that number, I'll divide the number I get here in logarithm from over 2. So we can say square multiply by 2, square root divide by 2. So, okay, this one, let's do this way. For this particular one, let's put square on top here. Let's put the square here to make it more difficult. Then let's now divide again by the square root of a number. Let's say we have 1.24. So how are we going to go? What are we going to do about this? Using logarithm. Let's do that. So first, how many numbers we have here? We have 3 numbers. This, and this. So for all the numbers, let's write them down in logarithm form. Already we've done for this already. 26.71 is 1.4267 in logarithm form. 307.7 is 2.4881. So let's focus on the numerator first. Now because here we have square, so we multiply this one by 2. And this one remains. So anything we get here and this we are going to subtract because of the division. For this, it remains 2.4881. Now let's multiply this by 2. We'll start from back. 2 times 7, 14, carry 1. 2 times 6, 12 plus 1, 13, carry 1. 2 times 2, 4 plus 1, 5. 2 times 4, 8.2. Now what next? Because we have division here, we have to subtract. So let's subtract and see what we are going to get for the numerator. 4 minus 1, that's 3. Here we have 13 minus 8, that is 5. This is 4, so 14 minus 8, that is 6. 7 minus 3, 10 minus 4, that is 3. Then we have 0 point. So that's what we get. Now let's move to denominator. We have 1.24. Before it's to get into that part. Now what happened? We have 1 point. This already is standard form. Since it is already in standard form, we can write this as 1.24 times 10 to the power 0 because 10 to the power 0 is still 1. So what we here is what? 0. Note, is the power of the 10 we put here 0 point. Therefore, 124 we check 12 under 4. Let's go to the logarithm table to check 12 under 4. So from here 12 under 4, this is 4. And that will be 0.934. 0.934. What next? Because I have square root here, so I will divide this by 2. And by the time we do that, 0 over 2 is 0. 0. 2 in 9, 4, carry 1. In 13, 6, carry 1. In 14, 7. So this is what we have at the denominator. So what happened? This is the numerator, this is the denominator. Let's write this under it. 0.0467. 0.0467. So between the numerator and the denominator we have division. And division we are going to what? Subtract. So let's subtract and see what we are going to get here. So from here, we borrow 1. 13 minus 7 should give us 6. This is 4. We borrow 1. 14 minus 6, 8. This is 5. Then we'll take 1 from here. So 15 minus 4, sorry. This is 5. This 6 comes to 5, so 5 minus 4, that is 1. 3 minus 0, that is 3. 0 minus 0, that is 0. So everything like this in log form is this. So if you take the antilog, of 0.3186, we get the original number. So we'll go to the antilog table now. So we check 31 under 8 difference 6. You can do that yourself if you have the table. 31 under 8 difference 6 should give you after adding the difference. So this is the antilog table. So 0.31 under 6 under 8 rather. This is 8. 31 under 8 is 2080. Then we have difference 6. Difference 6 is 3. 3. So we have 2080 plus 3, that's 2083. So by default, the decimal point is here. Then we have 0. 0 means what? We will not shift. And then we have 1 here, we shift ones forward. So like this one, the point was here originally. Then we have 3, we shifted 1 to 3. Here the point will be here. Since we have 0, we will not shift. So this is the final answer. You can confirm that from your calculator that the answer is 2.083. So if you press your calculator at the end of the day, you'll be getting 2.082, not 0.83. So the last digit will always be different by 1. So anything you get at the back of the calculator, you can just add 1 to it. In case you want to use calculator and the question is objectives and you're required to use the table. And I think this is, if you can solve this and this, you should be able to solve any question on logarithm, especially if all the numbers are greater than 1. So all the numbers here, these two numbers are greater than 1. So this logarithm of number greater than 1. What if we have numbers that are less than 1? It becomes more complicated, but no big issue there. Let's take an example. Check out this third example. We have 4 numbers here, and out of these 4 numbers, 3 of them are less than 1. This is the only one greater than 1. So we are following same step. So the only thing is the integer part. So for this one, in standard form, if we have 0.0257, this 1, 2, that's 2.57 times 10 to the power minus 2. When we shift to the right, it's going to be minus 2. So the power here is minus 2, we are going to write it here. Point, then we'll check 25 under 7. 25 under 7. And that is 4099. 4099. But if you write it this way, it's going to be wrong, because if you have minus 2.4099, it means this 2 is negative and 0.4099 is also negative. But the thing is, this part is actually positive. So instead of us to put the minus here, we'll put the minus on top of this 2. We call it bar 2. So this shows that the negative is only for this 2. The other part is positive. Same thing goes for this one. We shift this one how many times? Twice. 1, 2. Standard form. That's bar 2. Then go to the logarithm table, check 52 under 2. 52 under 2 should give you 7177. So let's do the same thing here. This is already in standard form. So we're not shifting at all. That's 0 point. Then we'll check 52 under 9. For this one, you have to shift it here. 1. That's negative 1. That's by 1 point. So if you check 52 under 9, you check 11 under 1 for both, you are going to get. So we get this. Now what next? For the numerator, we have no too much issue. We have no issue. So we have multiplication. So in that case, we are going to add these 2. So after adding, what will be the answer? For this one, we have division. We are meant to subtract, but because of this square root, it means this number we have to divide by 2 first. So after dividing by 2, we get the number. This one remains as bar 1.0453. So let's add this together. So by adding, 9 plus 7 is 16. So that's 6 carry 1. Add 1 to the, that's 10. That's 17. 7 carry 1. That's 2. Then 4 plus 7 is 11. So that's 1 carry 1. Bar 2 plus bar 2 is bar 4. Plus that 1 is going to go bar 3. Bar 2 plus, sorry, bar 4 plus 1. Bar 4 is minus 4 plus 1. That's minus 3, which is bar 3. So we have that. So let's divide this by 2. 0 divided by 2 is 0. 0.2 is 7. That is 3 carry 1 in 12, 6. In 3, 1 carry 1. In 15, that will be 7 carry 1. We still have 1 remainder over 2, that's 5. So approximately that will be 8. So we are done with this. So what next? We have division. So here we subtract. So by the time we subtract this, what are we going to get? So 8 minus 3, that is 5. So for 1, we have to borrow 1. 11 minus 5, that will be 6. This is now 5. 5 minus 4, that will be 1. 3 minus 0, that will be 0. Let's do it again. 8 minus 3, 5. 11 minus 5 is 6. Then this becomes 5. 5 minus 4 is 1. 3 minus 0 is 0. Then 0 minus bar 1. 0 minus bar 1. That's 0 minus bar 1 is what? Minus 1. 0 plus 1, that is 1. So here we are having what? 1. This is for the denominator, and this is for the numerator. What next between denominator and numerator? We have the division. So meaning we are going to subtract this from this. So we have what? Bar 3.1276 minus what? 1.0165. So let's subtract again and see what we're going to get. So 6 minus 5 is 1, 7 minus 6 is 1, 2 minus 1 is 1, 1 minus 0 is 1, point. Bar 3 minus 1, bar 3 minus 1, same as bar 3. That's minus 3 minus 1, that's minus 4, that's bar 4. But we're not stopping here. Why? Because we have cube roots. These cube roots. Cube roots in this case means we are going to divide our answer by 3. Now this is the biggest problem. How do we divide this? You recall I told you this and this, they are different. So we can separate it as about 4 plus 0.1111. So we want to divide each by what? By 3. In order not to make error, we have to ensure that this bar 4 is a multiple of 3. So we have to make this bar 4 to be a multiple of 3. So it's either this one is bar 3 or it's bar 6. But it's better we increase this or we reduce to bar 6. So if we turn this bar 4 to bar 6, what actually happened there is it means we added minus 2 here. Because minus 4 plus minus 2 gives us minus 6. So if we add minus 2 here, meaning if you add negative 2, to cancel the effect you have to remove negative 2, which is add what? 2. So we are going to add minus 2 here and add plus 2 here. So at the end of the day, we are not adding anything. So meaning this one becomes bar 6 plus 2.1111. This is still the same because if I do bar 6 plus 2, I'll get bar 4. Point this. So now we can now easily divide by 3. So from here, bar 6 divided by 3 will give us bar 2. Then we can now divide this. So if you have 2.1111 divided by 3, we're getting 0. Let's do it together. 3 into 0, that's why 0 point. Then 3 in 21, that will be 7. And that's 0. Then 3 in 0, 1, 0. 3 in 0. Then 3 in 11 should be 3 times 3, 9, and 2. Then the 2 behind that. So in 21 it will be 7. So and that's the answer. So I think one of the most complicated parts here is how to divide, this. So at the end of the day, the whole of this equals this in logarithm form. So what next? To get our correct answer, we have to take the antilog. The antilog of bar 2.07037. So we start from what? 0.70. So check under antilog table. 70 under 3 difference 7. What will be our answer? This is our antilog table and this is 70. So 70 under what? Under 3. 70 under 3. That is 5047. Then difference 7. This is under 3. Difference 7. Difference 7 is 8. So I'm going to add 8 to it. So that will be 5055. By default, the decimal point is here. So bar 2, meaning we are going to shift this time around backward. And then when we have 2 here, we'll go forward. But because we have bar 2, we go backward 1, 2. So if you have 5.055, so go 1, 2. Decimal point will be here. So to be extra 0 here, another 0 here. That's 0.05055. So the final answer after doing the antilog is 0.05055. And that is the final answer. Oh, sorry, I just discovered that I made a slight mistake here. Doing the subtraction here, 3 minus 0 is 3. So this is meant to be 3. So doing the subtraction, what we have here should be 3. And after that, let's do the subtraction again. 6 minus 5, 1. This 1. 2 minus 1 is 1. Then 1 minus 3 is not possible. So borrow 1 here, and this becomes 11. So 11 minus 3 gives 8. If you borrow 1 from bar 3, it becomes bar 4. Because from minus 3, if you remove 1, that's bar 4. So we now have bar 4 minus 1, and that will be bar 3. Sorry, this becomes bar 4. Bar 4 minus 1, that's like bar minus 4 minus 1, that's bar 5. So this is bar 5. Then this time around, what I have here is bar 5. So to make it multiple of 3, we have to turn this one to bar 6 by adding bar 1 here, then we add 1 here. So this must be 1. So but 6 over 3 is 2. Then if you divide 1.111 by 3, so 3 in 1 is 0, that's why I have points here. 3 in 11 is 3. So let's do division again. So let's do it again. 3 in 1, 0, then 3 in 11, that will be 3, remainder 2. In 21, 7, remainder 0 in that 0. Then remainder 1. Then in 11 again, that will be 3. So that will be. So we continue, the next number will be 6. So to 4 decimal places, this will be 4. So for the antilog, here is about 2.3704. So you have to check 37 under 0 difference 4. So by the time you check 37 under 0 difference 4, we are to get. So we are going to get 2346. The decimal point originally will be here. Then we go over this about 2, we shift backward twice. So we have 2.34612. So that will be 0.023464. Is that correct? 234. Okay, this 4 is not there. So that will be approximately 0.0235 as our final answer. I hope there is no mistake here. And that is something about this topic. If you're not careful, you are going to make a lot of mistakes. So for example, here, I corrected the mistake here, but it doesn't reflect here. So this one is meant to be 8. So that will be 1.811. So this is still correct. Then the other part will be the wrong one. So if you divide 1.8111 by 3, we should get 0.6037. So this time around, I hope no error. Let's look for the antilog. 60 under 3 difference 7. We will get 4015. Decimal point is originally here. Then we shift twice backward. 1, 2. So the final answer is 0.04015 as the final answer. Okay, now I'm 100% sure no error here because I've confirmed this directly with the calculator. So rule number 1 under this topic, be careful. A slight error, your final answer will be wrong completely. Okay, let's solve one more question under this to end this segment. Okay, same thing, we have 3 numbers here. Alright, for each of the numbers, to the standard form, it will be 1, 2. We shift it here twice, that will be about 2. This one, from here, we shift backward, 1, 2. That's 2, number 2. If you shift to the left, it will be positive. To the right, it will be what? Negative. This one to the right, it's also going to be negative. 1, 2, 3. That's about 3. So we'll go to the logarithm table. 7, 6 under 3, right here. 3, 0 under 9, you write it here. 8, 4 under 6, difference 5, you write it here. So what next? For numerator, we have no issue. For denominator, we have multiplication, meaning we have to add this. So let's add this and see our answer. This will be 7. This will be 7. 9 plus 2, 11. That will be 14. Carry 1. 1 plus 2 is 3. 3 plus bar 3 is 0. 3 plus bar 3, sitting as 3 minus 3, 0. So this is what I have left for the denominator. So this is our numerator, bar 2.8825. So denominator we have what? 0.4177. In between here we have division, meaning we have to subtract. Let's subtract and see what we are going to get from here. So 15 minus 7 is 8. This becomes 1. 11 minus 7 will give us 4. This becomes 7. 7 minus 1, 6. 8 minus 4, 4. Bar 2 minus 0, bar 2. So this is what we have. So everything inside here is this. But outside here we have 4. So meaning we have to divide by 2.4648 by 4. So we have to turn this one to multiple of 4. So this becomes bar 4. We added what here? Bar 2. So we're going to add 2 here. So that will be plus, if you add 2 to this one, that will be 2.4648. Then we cannot divide by bar 4, by 4 rather. Alright, from here, bar 4 divided by 4 gives us bar 1, plus 4 into 2 is 0, then 4 into 24 is 6. Without 0 is 0, 6, that is 1, without 2. Into 4, 6. Without 0 is 0, 8, it is 2. So that's bar 1.6162. So we are going to do the antilog of bar 1.6162. So now we go to the antilog table and check 0.61 under 6 difference 2. We get 4132. The point is here. Bar 1 means we shift backward once. 0.0. So the answer is 0.4132. This time around, no error. So this is the correct answer. Let's take the last question. Now look at this question. It looks simple, but if you're not careful, you get it wrong. Because in law of logarithm, we turn times to plus, but we don't turn plus to times. Meaning, if you have log a plus b, the answer is not log a times log b. So what are we going to do in this case? We solve this one to the last answer. We solve this one to the last answer, then we add normally. So here we can do direct addition. But 8.3 power 3 might be difficult without logarithm table. So we'll do it separately for both. So for this, we are not shifting. So that's 0 points. Same thing here, 0 points. Then we look for 83 under 0. 17 under 0. Then 2 answer, we look for the antilog. We add both. After adding both, we will now what? We return back to the answer we get a log form. Then after that, we divide by 3. Then the answer will do the antilog. That's the end. Do it yourself and let me know the answer.